Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Backup strategies are an essential safeguard in IT, protecting data from loss caused by hardware failure, human error, or malicious activity. A well-designed backup plan ensures that information can be restored to a usable state even after serious disruptions. For the Tech Plus certification, you will need to understand concepts related to both file-level and system-level backups, the locations where backups are stored, and the recovery methods available. In this episode, we will examine how backups are created, maintained, and used to ensure data resilience and business continuity. The primary purpose of backups is to preserve critical information so it can be recovered after it has been deleted, corrupted, or compromised. They act as a safety net against risks such as accidental file deletion, ransomware attacks, and system failures. An effective backup strategy reduces downtime, restores operations quickly, and reassures users that their work is protected. In many industries, maintaining backups is also a legal or compliance requirement, making them a key element of regulatory readiness. The types of data chosen for backup depend on its value and the role it plays in operations. This can include personal files, production databases, application settings, and system configurations. File-level backups focus on preserving documents and user data, while system-level backups capture the operating system and all supporting files needed to boot and run the environment. IT teams decide the scope of each backup based on data criticality, recovery objectives, and the acceptable amount of downtime in the event of a failure. File-level backups target specific files or folders rather than the entire system. This makes them efficient for preserving user-generated data or frequently updated documents without consuming excessive storage space. File-level restores are selective, meaning individual files can be recovered without reinstalling the operating system. These backups are often paired with versioning, which keeps multiple copies of a file over time, allowing rollback to earlier versions if a mistake or unwanted change occurs. System-level backups capture a complete image of the operating environment, including the operating system, device drivers, applications, and user settings. This type of backup enables bare metal recovery, where a system can be restored from scratch onto a new or wiped machine. While system backups take longer to create and require more storage, they are essential for restoring servers, enterprise systems, or complex configurations after catastrophic failures. They provide the most complete form of recovery in disaster scenarios. A full backup captures all selected data every time it runs, ensuring that one backup file contains everything needed for restoration. Incremental backups, by contrast, only store changes made since the last backup, significantly reducing both backup time and storage requirements. While incremental backups are more efficient, restoring from them often requires retrieving data from multiple points in the backup chain, which can make recovery more complex. Understanding when to use each method is vital for balancing efficiency and recovery speed. Differential backups store all changes made since the last full backup, regardless of when they occurred. This approach strikes a balance between full and incremental backups by making restores faster. Only the full backup and the most recent differential are needed. However, they consume more storage than incrementals because they repeatedly save the same changes until the next full backup. Differential strategies are often used in environments that prioritize quicker recovery while still managing storage costs. Snapshot backups capture the exact state of a system or set of files at a specific point in time. Commonly used in virtualized environments, snapshots provide a rapid rollback option if a change or update causes problems. They are quick to create and can be used to return to a known good state almost instantly. However, snapshots are typically not suited for long-term archiving and are most effective when paired with other backup types for comprehensive protection. Backup scheduling and frequency directly affect how much data might be lost in the event of a failure. The more frequently a system changes, the more often backups should be taken. Business-critical files may require hourly or even continuous backups, while less dynamic systems may only need nightly or weekly backups. Many enterprise setups use a combination nightly full backups with frequent incremental backups during the day. Skipping scheduled backups increases the risk of data loss and extends downtime after an incident. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Choosing where backups are stored is as important as deciding what to back up. Local backups are saved directly to the same device or to an internal drive, providing the fastest backup and restore speeds because they avoid network transfer delays. External backups use removable storage, such as USB drives or external hard disks, which can be disconnected for safekeeping. Network-based backups save data to file servers or network-attached storage devices on the local area network, allowing centralized management. Cloud backups store data off-site on remote servers accessed through the Internet, offering geographic separation for disaster recovery. Local backups are valued for their speed and ease of access. Because they are stored on-site, recovery from accidental deletions or small-scale failures is quick and requires no internet connection. They are easy to manage and can be automated with simple scheduling tools. However, local backups are vulnerable to physical risks such as fire, flooding, theft, or ransomware attacks, meaning they should be combined with other methods for maximum protection. Cloud-based backups offer geographic redundancy, ensuring that data remains safe even if the local site suffers a disaster. They support automation, scaling storage as needed without requiring physical upgrades, and can be accessed from anywhere with proper credentials. Cloud backups reduce the need for on-site hardware maintenance, but rely on network bandwidth for both backups and restores. Subscription fees and ongoing costs should be factored into planning, along with security considerations for data stored off-site. Hybrid backup strategies combine the strengths of both local and cloud storage. Local backups allow for fast recovery in most situations, while cloud backups protect against site-wide failures. This approach is increasingly popular because it offers speed, redundancy, and resilience in a single plan. For example, a file might be backed up locally every hour and synchronized to the cloud daily, ensuring both quick access and off-site protection. The media used for storing backups varies based on capacity, speed, and durability needs. Common consumer options include USB flash drives, external hard drives, and SD cards, while business environments may use network-attached storage, optical disks, or enterprise-grade tape systems for long-term archival. The choice of media affects not only how quickly backups can be written and restored, but also their portability and lifespan. All media should be tested periodically, maintained properly, and replaced before failure becomes likely. Securing backups through encryption is critical, especially for data stored off-site or in the cloud. Encryption ensures that even if the backup files are intercepted or stolen, the data remains inaccessible without the correct decryption keys or credentials. Security measures should also extend to how encryption keys are stored and managed, as losing these can make the backup unrecoverable. Strong authentication and proper access controls help maintain backup confidentiality and integrity. Validation and testing confirm that backups will work when they are needed most. Regularly restoring sample files or entire systems from backups ensures the process functions as expected and that the data is intact. Backup logs should be reviewed to track the success or failure of jobs, detect corruption, and measure backup duration. Scheduled testing reduces the risk of discovering too late that a backup is incomplete or unusable. Retention policies define how long backups are stored before being deleted or replaced, while versioning allows multiple historical copies of files to be kept. Balancing these factors ensures compliance with legal or contractual obligations while managing storage costs. For critical systems, extended retention periods may be necessary to meet industry regulations or to safeguard against long-term issues. Versioning can also be invaluable when recovering from accidental overwrites or gradual data corruption. On the Tech Plus exam, you may be asked to identify the differences between full, incremental, and differential backups, or to choose the most suitable storage option for a given scenario. Questions could also involve evaluating encryption requirements, validation practices, or retention policy trade-offs. A strong understanding of these concepts prepares you to design, manage, and troubleshoot backup systems in real-world environments. Key glossary terms for this topic include full backup, incremental, differential, snapshot, local storage, cloud backup, network-attached storage, retention policy, and encryption. Grouping these terms by backup method, schedule, and storage location helps you quickly recall them under exam conditions. Practicing short explanations for each term reinforces understanding and ensures you can apply them to both exam questions and workplace scenarios. In IT operations, backup management is a shared responsibility across multiple roles. IT support staff often help restore lost files for end users. Administrators configure backup schedules and monitor job completion, and security teams oversee encryption and compliance with retention requirements. Reliable backups are a critical component of business continuity planning, enabling organizations to recover quickly from disruptions and continue delivering essential services without significant loss. In the next episode, we will begin Domain 6, Security, starting with the foundational concepts of confidentiality, integrity, and availability, as well as privacy principles and security frameworks. You will learn how these ideas underpin modern IT security practices and how they are applied across systems, policies, and compliance efforts. Join us for Episode 50, Security Concepts, CIA, Privacy and Frameworks. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.